Alrighty, here we go. We're going to talk about parent functions because the idea is that we're going to be looking at functions and understanding what they do, and there's a lot of different functions we're going to be studying over the course of the year. So what we're doing here is we're introducing you to all the different types of functions we hope to study throughout the course of this year, and that you'll see some very certain characteristics of them, and then we can also look at transformations of them later, and you'll be able to see that basically the transformations are essentially all the same. Like they do this, they kind of have the same look. It's just that the functions change, and that's about it. But transformations themselves are about the same. Anyways, we want you to understand, or I want you to understand characteristics of different families of functions. So, what is a function first? A function is a relation where for each x there is a unique y. In other words, x never repeats. What that means, is that if you were to do a vertical line test and just kind of go across like this, and I hope this comes out looking right. If you go across like this, you can see on this one that has yes, there is never a point where the graph is touching this vertical line twice at the same time. Over here, you can see there's points where that is touching twice at the same time, and thus that is saying not a function, because right here, let's say here and here, you have x repeating because you have, let's say that was a -2, 2, and you have a -2, -1. So you can see the x repeated, and it has two different y's. So what they mean by saying there's a unique y is that there's only one, for each one of those x's, there's only one point, one y that corresponds to it, to create a point. Now that doesn't mean that you can't graph non-functions. I mean, you can see that I've done that, and you've had some before. A circle can be done through some stuff that you will learn in pre-cal, but it's a non-function. So for the purpose of what we discussed, that's not something we're going to look at. All right, so what are we going to look at? Well, let's start off with these right here. Now, I will provide this worksheet to you, so you don't necessarily need to have this. You will get a worksheet of this on Monday. So don't worry about necessarily copying this down and making this chart. Anyways, you have your first one is a constant. A constant is just that y equals a number. And realize that when I say f of x is like y. So y is equal to, or f of x is equal to just a number. And what does that produce? It produces a horizontal line. Okay? We will look at domain and range in class as a group. Okay? Okay. Linear functions, those are the ones you've seen before, and those are the ones that are straight lines, diagonal lines of sorts, and they basically have that's about it. Now what we say when we call a parent function come back here, function is the most basic function within a specific family of functions. So what I mean by that is if we look at linear functions, okay, we know y equals x, and that's your most basic one that goes like this, well, sort of like that through the origin at about a 45-degree angle. But if I do something like y equals 2x plus 1, that's in the family of linear. When we say family, we're talking about that group. Okay, the parent is the one that sort of bears or gives birth to all the others. That's why it's called a parent function. So 2x plus 1 might go through here and be a little bit steeper, that type of thing. Okay, and so that's a transformation. So basically the most basic one is the parent. Okay, and that's the one that we kind of observe all the other rules for. You can see for a quadratic, we've got f of x equals x squared. That gives us our u-shaped graph, which again is called a parabola. Parabola! No, not a parabola, a parabola. A cubic function which has a specific type of curve. You've got a square root function which starts at the origin and kind of goes sideways to the right, but it's still also going up. Keep that in mind. The absolute value function, which is a v-shaped graph. And then the next ones would be logarithmic, exponential, and rational. Okay, so you can see here with the logarithmic function, we have a curved line that looks like it's getting close to the the y-axis on the left. We'll cross the x-axis and then start to go up on the right and over to the right. The exponential function is kind of the opposite of that. So logarithmic and exponentials are kind of opposite of each other. That one crosses the y-axis it is approaching or getting close to the x-axis on the left side, and then goes up as you go to the right. A rational function is where we're dividing, something we'll hopefully get to at the end, and you can see there they have like two curves that are on opposite corners of each other. So again, we'll discuss these more, and we're going to go through this on this table, and there's a page, but just to introduce you to the idea of these are the parent functions we plan on going through, and we'll go from there. Anyways, that's it for today. Thank you very much. Y'all take care.